Hi everyone, in this video we're going to talk about solving quadratic equations by factoring. This is just one of several methods that you can use to solve them. So what does it mean to solve? So recall that this means to find the value or values of the variable, or variables if you had more than one, that make the equation true. So we've looked at some linear equations like this one, 3x plus 2 equals 6. So to solve this, we need to find the value of x that makes the equation true. Now if you just have a single variable like x, then it's easy enough to solve by isolating that x. So I could subtract 2 and get 3x equals 4, and then divide by 3, and x equals 4/3. So that was our method for linear equations. Now, quadratic equations are a little more complicated. So let's say we had x squared plus 2x plus 3 equals 0. Make this a minus 3. All right, now to solve this, let's say I try that same method, getting x by itself. All right, well, first of all, which x? I've got an x squared and a 2x. So let's say, you add 3 to both sides. All right, maybe we subtract 2x. All right, and eventually you're going to kind of get to a dead end here. Some people square root this. X equals square root 3 minus 2x. And all of these things are true. There's nothing incorrect about writing these statements. The problem is that we haven't reached the goal of finding a numerical value for x. So in this case, I've got a different way of writing the equation, but it still doesn't tell me the number for what x equals. So play around with that if you like. If you try any of those linear methods, you'll end at the same kind of a dead end. So instead, we need to use different methods to solve quadratics than we would linear equations, and the first of these is factoring. So there's a property that we need to use in order to understand why solving by factoring works, and that is the zero product property. Now this property says that if you multiply two numbers and the answer is 0, then this property tells us what are the values for a and b. All right, what are the restrictions or requirements for those variables? So think about some possible values for a and b that would make this work. All right, what are two numbers that when you multiply together equal 0? All right, so you can come up with your own, but here are a couple examples. 0 times 5 is 0. All right, so a could be 0, b could be 5. We could have that reversed, so we could have like a be a number that's not 0, like 4. 4 times 0 is 0. Okay, so a could be 4, b could be 0. I could have them both be 0. A equals 0, b equals 0. But notice any examples that you come up with that multiply to be 0, you're never going to have one where you don't have a 0 as one of those numbers. All right, so like -1 times +1, that's -1, not 0. Okay, some people do like positives and negatives, 2 and -2. And if you add, that's 0, but when you multiply, right, you'll never get an answer that's not 0. So here's what the zero product property says. It says that if a times b equals 0, then either a equals 0 or b equals 0. Or b equals 0. And it's implied that it could be both. It could, we saw that example. A and b could both be 0, but the minimum is that one of them has to be a 0. All right, so let's see how that property works for solving quadratic equations. So here are some that are already factored for us, and you've looked at factoring already, how to turn a standard form equation into something that looks like this. Right? Now we're just going to add in this piece about the zero product property. All right, so what I have here are two things being multiplied together that equal 0. So the zero product property tells me that one of those two things must be a 0. Now the only difference here is instead of talking about single numbers a and b, we have a parentheses acting as a and a parentheses acting as b. So in this case, like the a is the x plus 2, and the b is the x minus 3. So what I know is that either x plus 2 has to equal 0, or x minus 3 has to equal 0. Right? That's the only option for getting a 0 when I multiply those two factors. Okay, so what this does, right, so it could be one or the other or both. So what this does is it gives me two linear equations that I can then solve using those, perhaps easier linear methods. So if x plus 2 equals 0, then I can just subtract 2 from both sides and see that x equals negative 2. Right? And if x minus 3 equals 0, I can add 3 to both sides, and in that case, x equals 3. So what this is saying is that there are two answers to this equation. Both negative 2 and 3 make the equation true. All right, so let's try it. Let's check. So I'm going to check the same way that I did linear equations by substituting in those values. All right, so let me check them one at a time. So I'll do x equals negative 2 first. So we end up with negative 2 plus 2 times negative 2 minus 3 equals 0. All right. Now, if you're in kind of that algebraic quadratic mode, it's tempting to FOIL this to figure this out. All right, and you can do that, but it's also correct to simplify first. All right, so order of operations, I'll work out the parts in parentheses. So negative 2 plus 2 is 0, and negative 2 minus 3 is negative 5. Okay, and 0 times negative 5 is 0, so that does check out. And then we have a second check. We can also check the value 3, x equals 3. So we have 3 plus 2 and 3 minus 3. And that's 5 times 0, and that is 0, so that checks out as well. All right, how about the second one? 2x times 3x minus 4 equals 0. So same idea, but instead of two binomials here, I have a monomial times a binomial. But it's the same idea. In this case, a is 2x, and b is 3x minus 4. So then the zero product property says that either 2x equals 0, or 3x minus 4 equals 0. Okay, so then in this case, if 2x equals 0, then divide both sides by 2, and x equals 0. Or if 3x minus 4 equals 0, then I add 4 to both sides and divide by 3, and x equals 4/3. So this one also has two solutions. X could equal 0 or 4/3. Okay, and then finally the last one. This is not a quadratic equation, but I thought it was interesting and I wanted to show you that you can use this property to continue on and look at other algebraic equations that have more than 3 factors multiplied together. So same idea here, but in this case like a modified version of that property would say that if a times b times c equals 0, then either a equals 0, or b equals 0, or c equals 0. Okay, so same thing. I have x minus 5, and x plus 7. One of them must be 0, so then I set them each equal to 0. X equals 0, x minus 5 equals 0, x plus 7 equals 0. Alright, now the first one's already solved for x, so that's done. Second one, add 5 to both sides, x equals 5, and the third one, subtract 7, x equals negative 7. So this equation has 3 solutions: 0, 5, negative 7. All right, so that's how we solve by factoring. And here's the procedure. We have, your textbook has this written all out. So first, write the quadratic equation in standard form. Okay, rearrange it so that 0 is on one side. So that's ax squared plus bx plus c equals 0. Then factor the left side. All right, now these are quadratic, so you're going to end up with two factors like that, and then you might also have like a greatest common factor out here. Set both factors equal to 0. And then this gives you two simple equations, two linear equations, and you solve each equation. So we worked from this step on the already factored version, so now we just need to put the pieces together and take things from standard form into factored form, right, by factoring, and then go from there using the zero product property. So here's an example. X squared minus 13x equals negative 36, and we want to solve this by factoring. Okay, so step 1, I need to rewrite this in standard form, or equal to 0. So add 36 to both sides. And we get x squared minus 13x plus 36 equals 0. Then I need to factor the left-hand side of the equation. So I'm going to use that single factoring method, right, the AC method or that X method. Okay, so A times C, that's 1 times 36, and B is negative 13. So I need two things that multiply to equal 36 and add to be negative 13. All right, so I know there are going to be two negatives. It's either got to be two negatives or two positives, and they have to add to a negative number, so it's going to be two negatives. Okay, and if you think about it for a minute, you'll come up with, hopefully, 9 times 4, that's 36, and then negative 9 plus negative 4 is negative 13. All right, so this is the kind of a shortcut method, right? Since the coefficient in front of the x squared is a 1, then those two numbers do give me the numbers that go in the factors. All right, so I can skip through a lot of this factoring process, and this ends up as x minus 9 times x minus 4. Okay, now we have equals 0. So now we're working with equations, not just expressions. All right, we are not done. This is factored, but it is not solved. So if you see solve, that means actually find the numerical values for x. All right, so now I want to use the zero product property. I have two things being multiplied to equal 0. So the zero product property says one of them must be 0. So either x minus 9 is 0, or x minus 4 equals 0. And then I can solve for x. All right, so add 9 to both sides, and add 4 to both sides. All right, so two answers, either x is 9 or x is 4. Okay, same idea. Here's a second example. Solve 6x squared minus 6 equals negative 5x, and we're going to solve by factoring. So I need to write it in standard form first, so add 5x to both sides. Okay, in standard form, I want that in the middle term. And then I need to factor. Okay, so A times C is 6 times negative 6. That's negative 36. And then B is 5. All right, so again, 9 and 4 are going to work. And one of them needs to be negative since I'm multiplying to equal negative 36. So to make 5, it's got to be a negative sign on the 4. So 9 minus 4 is 5. So this is a little bit of a longer one for factoring. I can't just jump straight to the factors since I have a 6 here and not a 1. Alright, so let me go through the rest of this. So we have 6x squared. I'm going to rewrite 5x as plus 9x minus 4x. Then minus 6 equals 0. Then next I'm going to look at these in pairs of two terms and factor out the greatest common factor. Alright, so the greatest common factor of the first two terms is a 3x. And when I factor that out, that leaves me with 2x plus 3. And then out of the second two terms, I know I want to take out a negative. And then I'm hoping to end up with 2x plus 3 in these parentheses. So if I took out a 2, that would work. And that is the greatest common factor as well. Okay, so that leaves me with 2x. And now I'm taking out a negative 2. So negative 6 divided by negative 2 is positive 3. So this is going to be a plus 3. All right, and now these match the 2x plus 3, so I can factor those out. And that leaves me with 3x minus 2. And then the 2x plus 3 that I factored out. And that equals 0. Okay, so now using the zero product property, I can split those up, set them equal to 0. So either 3x minus 2 equals 0, or 2x plus 3 equals 0. And then solve for x. All right, so this first one, I'm going to add 2 to both sides, then divide by 3, and we end up with x equals 2/3. Okay, you can fill in the steps there. And then here I'm going to subtract 3 and divide by 2, and x equals negative 3/2. All right, so there we have it. Two different answers again. Now it is possible to get two of the same answer, and that happens anytime you have two factors that look the same. So if this had been a 3x minus 2 times 3x minus 2, then I would have ended up still with two answers, but both of them would be identical. Okay, so that's the gist of solving by factoring. So try a few other examples if you like, see if you've got the hang of it. But really we just pieced together what you already knew about factoring and then used the zero product property to take it the last step just to find the value of x that makes the equation true. All right, thanks for watching.